Now let's start with the plastic shader. I'm going to start interactive rendering. Select the top part of the shader ball. Create a new material in the node editor and name it plastic_red. Then select the bottom part of the shader ball and assign the same plastic red material to it. Obviously, we are going for a red plastic shader first. Now, for plastic shaders, diffuse and SSS colors are probably the most important component and contributor to the final look alongside reflection. And normally you want to have the same diffuse and SSS color. So add a new V-Ray user color node. Hey folks, welcome to MoGraph Plus. This video is a free sample from our course, The Ultimate Introduction to V-Ray for Blender. It's a massive 13-hour course where we dive deep into every aspect of V-Ray for Blender, everything you need to know step by step. If you'd like to master V-Ray inside Blender, make sure to check out the full course. You'll find the link right down in the description. And of course, don't forget to subscribe and hit the bell icon so you'll get notified whenever we post new tutorials and lessons. Change its color to a vibrant orangish red with the RGB values of 0.277, 0.054, and 0.022. For now, just use it as the diffuse color. Now come over to the reflection section and enable use roughness. For the reflections, as I mentioned in the reflection video, for most materials and shaders, you can safely keep the reflection color at white to keep the shader as physically accurate as possible. In the past, we used to control reflection color and roughness and then define very specific IR values for each shader. Just forget that. In this new PBR-based approach, reflection color is almost always just a simple white. And the IR value for most daily shaders like plastic, wood, concrete, and so on can be around 1.5. The only thing we are interested in is the reflection roughness. We add variation to the reflection roughness with a grayscale texture, and that adds all the realism we need. As we are dealing with plastic, let's change the IR to around 1.5. If you have any issue understanding these parameters, you can refer back to the previous videos where we explained them in detail. For reflection roughness, add a V-Ray bitmap node and load this BW_Mtl_01 texture. As this map will be connected to the reflection roughness, I'm going to change the color space to raw and transfer function to linear, and connect the texture to the reflection roughness input. And that's the result we get. This is not exactly what I want. It's too rough and contrasty. I want to be able to make the bright values of the texture quite darker so we wouldn't get this very rough surface. Probably inverting the texture will result in a better look as well. So let's add a remap node after the texture. In the remap node, first let's invert the values completely. Now to get a sharper reflection, we want to make the texture much darker because remember our input is reflection roughness, which goes from 0 or black or sharp to 1 or white or rough. Let's grab the first point and change its Y value to around 0.35. Now to avoid very sharp spots, we need to make the very dark values a bit brighter. So let's grab the right point and set its Y value to around 0.09. Cool, so that's our shader after adding the variation to reflection roughness. In terms of importance of components for plastic shader or anything similar, now we need to work on the subsurface scattering. So come down to the refraction translucency section and change the mode to SSS. And set the SS amount to around 0.75. Depending on the particular plastic, the SSS amount can be quite low or high. You need to look at your reference image and see if it has a lot of SSS or not, and then decide on the amount. Use the same red color that we used for the diffuse color as the SSS color and scatter radius colors. And let's set the SSS scale to around 10 centimeters. Because we are using a fairly dark color as the scatter radius and the scale is multiplied by the scatter radius, that's why I use the high scale value like 10 centimeters. And this really adds quite a lot to the overall realism of the shader. It's beautiful. The next thing to consider is to work on the bump mapping. For most surfaces, you need an overall unevenness that can be achieved with a simple noise, and then more high frequency detail, which you can just reuse the reflection roughness map for. So connect the original reflection roughness texture to the bump input of the material. We can increase the resolution scale to 200% and draw a render region to see how the bump mapping will look on a high resolution render. On a lower resolution render, you might be tricked and kind of increase the bump map beyond what you need. So that's why increasing the resolution and seeing the actual bump mapping effect on the surface on a high resolution render is very useful. And now we need to dial in the exact bump amount that is needed. Currently it's too much. Let's decrease it to 0.01. Still way too much for a surface like plastic. Let's try 0.001. Again, still way too much for a smooth surface like plastic. Let's try 0.00004. So 4 zeros. That's good. We don't want to exaggerate anything. Subtle and little is always better. So that's the high frequency detail. Now let's quickly add that general unevenness to the surface using a noise map. Most of the materials and surfaces surrounding us in real life are not made perfectly. It's not going to be perfectly smooth. There is some sort of waviness to the surface, and if you take a look at any reflective surface around you, you can see that overall waviness, unevenness to them. We can use V-Ray normal bump node or V-Ray bump material like we learned in the bump mapping video a few lessons back. So let's add a bump material. Connect the V-Ray material to the base material input of the bump material. And connect the bump material to the material input of the output node. Add a noise map. And connect it to the texture map input of the bump material. If I decrease the bump multiplier amount to 0.03 in the bump material node, so that's the type of unevenness that I'm talking about, but we want it to be kind of more subtle. So let's set the bump multiplier to around 0.0075. Now let's see what we get. This is a pretty good plastic shader and you can call it a day. One last thing that you can add to your shaders to make them more realistic is to make the perpendicular faces a bit sharper compared to the parallel faces to the viewing direction. We can do that simply using the coat section of the shader. We talked about this specific topic in the coating lesson. For now, let's set the coating amount to around 0.5 and coat IOR to around 1.1. So it will be limited to only the perpendicular faces. And set its roughness maybe 2.1. And this will add another level of realism to the overall shader. We can go ahead and add a bit of variation to the coat roughness, but this is enough for now. The good thing is that the whole shader is being controlled with this one texture that is connected to both the reflection roughness and bump input. If you load another texture, you would get an entirely different look. Let me show you the final high resolution render of this shader. Now let's quickly turn this into an orangish yellowish plastic shader. Click on the copy the active V-Ray material to a new one button from up here. Rename it to plastic yellow. Make sure both the top and the bottom parts of the shader have the same material. Now we just need to change the color in the V-Ray color node to any color we want. Let's go for an orange color with the RGB values of 0.501 for red, 0.261 for green, and 0.024 for blue. We can increase the subsurface scale if we want to get a softer plastic. And that's our yellow plastic shader. Let me show you a high resolution render for this shader.